So the question we're going to do today is question number 7 of our NeetCode playlist, which is product of array except self. It is a 238 question of a LeetCode. So what does the question say? Product of array except self. It is simple enough. Let's say this is our array 2, 3, 4, 5, 6. So for each element we want a same array, and for each element we want the product of the full array except current element. So for 2 it would be 3 into 4 into 5 into 6, that means 30 into 4 120, 360. For 3 it would be 2 into 4 into 5 into 6, 30 into 6 is equal to 180. 30 into 4 120, 240. 30 into 4 120 into 240. Okay. For 4 it would be 2 into 3 into 5 into 6, that means 6 into 5 30 into 6 180. For 5 it would be 6 into 4 into 3 into 2 is equal to 144. And for 6 it would be 2 into 3 into 4 into 5, because we do not take 6, each element is excluded in the product. So 6 4 24, 5 is a 120. Okay. So for this array we output this array. So how to do this? The simple approach is with the brute force approach, which we just did. For each element just do a loop again and don't consider this, and then consider every other element and solve a product. So for the first time I is here, we got this and we store it. For the second time I is here, we do the full loop but we don't count this and we get the product. And similarly for each element. So this is our O n square time complexity and O of n space, if we consider the output as a space. Otherwise it's just O m 1, because we do not use any external data structure, we just return the output as requested. So obviously n square is not that good, so we have to think of some better way. Now if we see a pattern here, we can see that the product of the full array stays same, but for each element's answer we just have to remove that from the product. So let's calculate the product at once. The product will go 2 into 3 into is equal to 6. 6 into 20 into 6. So that would be 36 into 20. That would be 720. So we have that product of full array is equal to 720. But the question is not asking for full product. It is asking for each product divided by the element. Because 3 into 4 into 5 into 6 is nothing but 720 upon 2, which is this. So we do the same for this. 720 upon 2 is 360. 720 upon 3 is equal to 240. Upon 4 is equal to 360 upon 180. Then divided by 5 we got 144. Divided by 6 we got 120. So you can see that we got the answer, and we were able to do it in one loop for calculating product, and then second loop for dividing each element by the product. But the question first of all specifically says that we cannot use the divide operator. This operator can be used, and even if we assume that let's say question is allowing us, you can use it, but still the constraints are very bad, so that we cannot calculate this without getting a TLE, time limit exceeded error, or maybe integer overflow error. Yes, integer overflow error is the main error, because the question says the max size of element can be up to 30, which looks small, okay, and the max size of the array, which is n can be up to 10 to the power 5. So in the worst case the array will be 30, 30, 30, 10 to the power 5 times. That means the worst case product will be 30 into 30 into 20, 10 to the power 5 times. That means 30 to the power 10 raised to the power 5. Now you might think this number is doable, so let me just tell you how big this number actually is. If we solve this number, we will get the number we will get, the full number. It will have around 1 lakh digits, because 30 to the power 1 lakh is almost equal to 10 to the power 1 lakh. And for reference, an integer, the maximum integer possible has around 10 digits, the maximum long possible has around 18 digits, and total number of atoms in the world, in the whole universe, that number has around 80 digits. So compared to that, this number is astronomically huge, so this is not doable. So now this question seems very tough to optimize it, but the question has one thing written in the question, that is in any case in the full array, the prefix, like let's say if this is the last element, then prefixes all these elements, or the suffix, that means if this is the first element, then all these elements, the product of prefix or of suffix in any case will be under 32-bit integer. That means it will always be in, like, it can be converted into an int, it can be like stored in an int, it will not do int overflow. Now you might say, well, if this much is int, then this will be also int. So let me give you an example in which this condition also fails, so that we cannot just use our own technique, because we have to follow what the question says. Let's say every element is 2 and the array size is 31. So in this case the product of full array is 2 to the power 31, and product of full array except the last element, that means a prefix, will be 2 to the power 30. So this is under integer, but this is not, because the maximum integer possible is 2 to the power 31 minus 1. and this integer is greater than this number. That means full product array is out of integer limits, but the prefix of the last element is under the limits. So that means this is allowed. So we have to find the logic in the prefix suffix logic. So let me take the example again, the starting array that we did, and let's see what we can do. So the array was 2, 3, 4, 5, 6. If we take an element, let's say we take 3, the answer for 3 will be 2 into 4, 5, 6. That means the prefix into the suffix. And for 4, the answer will be 2 into 3 into 5 into 6. That means for each element, the answer that we store in the final array is nothing but the prefix of the number and the suffix of the number in the array. So we can try to think of that in our next logic. So what we're going to do is, let me write it again because there are too many arrows. So the array is 2, 3, 4, 5, 6. We do one loop to calculate the prefix array, and we do another loop to calculate the suffix array. Prefix goes from here to here, like this says nothing beyond this, so we store 1. For 3, we have 2 into 1, so 2. For 4, we have 3 into everything before it, so 3 into 2, 6. For 5, we have everything before it, that means 4 into everything before 4, that means 4 into 6, so we got 24. For 6, we have to take everything before 6, that means everything before 5 into 5, that means 24 into 5, that means 120. Now similarly for suffix, we start from here, and suffix of x is nothing because there is nothing on the right, so we take 1. Suffix of 5, that means everything on the right of 5, that means 6 into everything on the right is 6, that means 6 into 1 is equal to 6. For 4, we want everything right of 4, that means everything right of 5 into 5, so 6 into 5 equal to 30. Similarly for 3, we got 30 into 4, 120. For 2, we got everything right of 3 into 3, everything right of 3 into 3, so we got 360. Now we got the prefix and suffix of each number, so for 2, we will just multiply this, we got 360. For 3, we will multiply this, so we got 240. 180, 144 and 120, which was the original answer. So we were able to do this in O of n time and O of n space. One loop to make prefix, one loop to make suffix, and then one loop through these two arrays to calculate the final answer. And space we used are two arrays, so that is O of n and O of n. Now we used two arrays, but if we try to think about this, what we did, for each number, like let's say if we are going for prefix, for each number we just need the prefix at this point. Like let's say the array is very big and then 4 is here. So why are we storing the prefix of every possible array? Like 2 prefixes 1, 3 prefixes 2. We just want this one. Like let's say for 6, we just want the prefix of 5, that is 24. We don't care about all these numbers. Why are we storing these? The array is like over complicated because we are taking too much space. Like we can further optimize this. So let's try to do this in just O of 1 space, that is constant space. No matter how big the input array, the space will be same, O of 1. So what we're going to do is, we will make the answer array, because obviously there should be an array output, so this is not extra space. So what we're going to do, let me just erase this again, so we got a clear example. Array stays same, 2, 3, 4, 5 and 6. So right now we just assume that this is a prefix array, because the answer array has to be made, we cannot reduce this space. So the prefix of 2 is 1. We do the same process as we did earlier. Prefix of 3 is 2 into 1 equal to 2. Prefix of 4 equal to 2 into 3, that means 6. Prefix of 5 is equal to 6 into 4, 24. Prefix of 6 equal to 5 into prefix of 5, 24. So we got 120. Now for suffix, we do this loop. Now we cannot use this array as a suffix array because this is already prefix. We have to store the prefix values, we cannot delete them. So we cannot just put 1 here as a suffix. So we have to use a one variable, which will be our constant space. So we will always use one variable extra. So let's say the suffix variable is equal to 1 right now. That means the suffix here is 1. Okay. So we got this. Now we multiply the prefix by suffix, because we have to convert this array into final array. So we 120 into 1 equal to 120, so it says same. Now we go to this element, but before that we multiply this to the suffix, because when we reach this element, that means this matters suffix. So the earlier suffix into the current element is equal to latest suffix. So latest suffix is 1 into 6, that means 6. For 5, we already have prefix and we have the suffix also now, so that means 6 into 24. So we calculate this here, so we got 144. Now we multiply 5 into this, so we got 30. I mean for 4 we have prefix here and suffix is this 30, 6 into 5. So we multiply 30 into 6, we got 180. For 3 we want the suffix and the prefix. Suffix is 4 into 5 into 6. We multiply 4 here because every element that we calculated solve the value to, we will multiply this to here. So we got 6 into 5 into 4, which is 30 into 4 equal to 120. So for 3 we get prefix into suffix 240. Similarly, and then we multiply 3 here. Similarly for 2 we have prefix here and suffix is here 360. 360 into 1, we got 360. So now we can see we got 360, 240, 180, 144 and 120. So this is a final array. We were able to do it in O of n time because there's one loop, and O of 1 space because we only use this variable extra and nothing extra space. So this was the most optimized way to solve this. And okay, that is it for today. Thanks for watching, and I will see you in the next time.